Hello and welcome to this video where we'll go into the basics of Pydantic that we can work with data in an OOP manner. We'll work with fields, methods, validate data, and we'll output JSON data as well. In order to show you the power of Pydantic, we'll start with a normal OOP class. And then based on this one, we'll do manual validation to see how that works, and we will go over to Pydantic. And Pydantic is very useful for things such as FastAPI. But if you're also interested into AI and LLMs, then you will notice that Pydantic is required and used a lot in order to structure the output, as that the output from LLMs are usually very unstructured, and you want to have it in a structured format and validate its output that you can use it more in later stages of your applications. Let's dive directly into the code. Here I will start with doing some setup, and if you have watched a lot of my videos before, I've usually used UV for package managing. However, I've used it in a more traditional way. I will start in this video, and in future videos I will go into more modern way of using UV. For doing that, we'll start with UV init. This one will start a UV project, and here I want to, you can see there's a main.py. Actually, I don't need that. I will remove it directly. And you can see Py project. Here is some description of our project. And here you can see which version of Python I'm using. Then we do UV add. And here we don't need to activate the virtual environment in order to install things into it as we have done before. Instead, you just do UV add. What do we need to add? I want to add Pydantic. And I want to have IPyKernel since I will be in Jupyter Notebook. And if I need something else, I will do it on the way. UV add, I've installed a few things, and you can see there's a Py project here. Here they show the different dependencies that exist, and you can see UV lock is actually all the installations. Now, when we have done this one, it's time to get started with whatever I'm going to do. I will clear my terminal and I will do touch. Let's see. Pydantic basics.ipnd. This is my Jupyter Notebook, and here I will work. I will start with Pydantic fundamentals, and I don't need my terminal anymore. I close it down. I need to choose my virtual environment, and I choose this Pydantic basics. Change this one to Python. And that is it. Now I'm ready to start working. We'll start without Pydantic first. Start without Pydantic. To start without Pydantic, we create an example, class person. What should this person have? Let dunder init. I want to have a name, a gender, an age, and I want to type hint it. String, gender string as well, and age I will have, let's say, int. That is quite nice starting point as a type hinting, and it returns none. Note that we will assign the values from the parameters here into the object itself or into the instance itself. Then we need to use self. Because the thing is, I'm taking this from the ground up, that you should have OOP background. You should have done some OOP in Python before. But if you haven't, I think it should be manageable to follow along anyway. That's why I'm explaining a lot of OOP in very fundamentally. Here, basically, the self, it's when you're instantiating a instance from this person class, it will inject itself into the self parameter. Then it will have everything. We can reference attributes and the methods using the self. That's why we do self.name equals to name. That means that we'll bind this variable name into the instance itself. Then I will do copy this a few times. And I will do self.gender equals to gender. And here I will do some VS Code magic, Command D. It means I mark these two. And I will change it to age. Nice. Some small magic. And now I have this person class. Now let's try to instantiate the person. Person1 equals to person. And here I will have name equals to Coction. And age equals to 34. And gender equals to male. Something like this. And then if I write person1, you can see that, this is the default done the wrapper of my person. That's why it just says a person in a particular memory address. However, if I do person1.name, you can see, I get Coction. Person1.age, I get the age, and 1 as 4. This is how I get my attributes. I use the dot notation to do that. Let's try out something else. We can do like this. Person2 equals to person. Name equals to, this one will work. Gender equals to true. This is totally crazy, but it will work. Age equals to -10. That works. Like, there is nothing preventing it to not work. Even if I hover it, you can see that we have name as a string, gender as a string, age as an int. But these are just type hinted. That's type hinting. It's not statically, it's not a hard typed language in Python. That means that even if we have type hinted, we said that, name should be string, gender should be string, age should be int, but nothing hinders the user from actually putting in crazy values like this. If I do person2, you can see it works. Very strange, but actually it's not strange because, as we said, Python is not hard typed as in other languages many other languages such as Java, C#, Rust, and C++, and many more. In Python, there's a lot of freedom, but it comes at a cost. The freedom is that, it is very easy to work with Python and start building stuff. But when you start to come to the certain point that you need to have validation, you need to have a lot of different things in order to make it like robust, then Python is actually hard to scale and make it more robust. So you need to learn some more packages. I will show you something like this. We will try to validate this code now to try to make it more robust. I will do validation of our person class. To validate this one, let's just go up and copy what I have here. I'll copy this. Paste it here. This should be a Python cell. Let's check this out. We want to check the name, for example. I want it to be string. If not is instance name, string, then we shall raise a type error and say that fstring name must be of type string, not whatever you put in. What did you put in? You put in type of name. If I do like person3, for example, or I can try and fail one here. Person name equals, say, 3.1415. And you can let the other ones be there. You can see there's a type error now. It says must be of type string, not class float. Great. Let's try and accept this. Try accept as L print error. I get the error. And let's see. Why doesn't this work? Accept except type error, of course, like this. And now you can see, it works. It has given a validation here. It's stopping me to actually put in a name, and that is not a string. Let's continue. I will copy this one. And I want to try out to, how about if I do, say that name is, we say person 3, because I haven't used that one. Name equals to Ragnar, and your age 54. Or actually, we take minus 54 because someone has accidentally clicked on the minus button. Unfortunately, person 3. Actually, I will just write then the wrapper here so that we get a nicer representation. Then the wrapper return f string of person. Let's see, cell dot name, comma, cell dot gender, comma, cell dot age. This done the wrapper. You can see now when I'm running this person 3, I will get, in Jupyter Notebook, they will use the wrapper by default for the last statement or the last line here. Here you can see person 3, and this is then the wrapper of it. It returns person, and then self.name, Ragnar, and then gender, M, and age minus 54. There is an issue here now, and the issue is that we are able to have a negative age, and that is bad. In order for us to have a better, we need to validate on the age as well. However, we don't want to validate, because if you, for example, I will show you one way. If not is instance value, comma, int, for example, if we want to have int, we could have float as well, but let's make it a little bit simpler. Raise, type error, f string, age must be of type int, not type age. Yeah, exactly. Not type age. And we shouldn't have value here. Instead, we should have age like this. And we need to protect it also with that it cannot be negative. If age, we need to have age is larger than 0, larger equals 0, because it can be 0, less than 125. And we have raised a type error here, or value error. A string age must be between 0 and 124, not value, which you have provided, or not age. Yes. Now we should get an error. Let's see, we should get an error now, because we have age. If not age is in this interval, now we should get an error. Good, we get value error. Now I want to accept value error. This one is actually the old one, that's why it's staying there. You can see age must be between 0 and 124, not minus 54. Great, that works. However, what if we want to do something in the style of this? Person, let's take another person that will work. I will copy this one. Person 4 we can take. Equals to Bella. You are 4 years old and you're a female. Person 4 is called Bella. And this one works. However, if I do person 4 dot age equals to -5, it works as well. Strangely enough, you can see it works. However, we had validation. Let's take a look. The validation, you can see it's when it's in the init, it's in the dunder init that we have this validation. The validation is only in the dunder init, and it's not, when we're changing the value, it's not affecting it, because it's only when we are instantiating an instance then that the dunder init will run. Afterwards, it doesn't run anymore. What you need to do in order to validate this is to actually put in something called a property. If you're from other OOP languages, you will probably understand property with getter and setter. In Python, we have property with getter and setter as well, but the syntactic sugar is quite nice when we use something called a decorator. I'm sorry for you guys that haven't studied enough OOP, but if you need to review OOP, take a look into my other videos where I have taught a lot of OOP as well, Python OOP. But I want to just make a point now with the how to do the validation. I copy this person, and let's try to fix this issue here. What we need to do is something called @property. I want to create this age cell. This is the getter of age. What it does is return self._age. Underscore is the backing private variable, private by convention is the variable which we won't touch basically. This is the getter. And then we have a setter that is called @age.setter. The age, and here we have self, value. Or we can have self, age actually. This one will work. And you can see here is all our validation code for the age setter. Whenever we do something in the style of actually self._age equals to age, and we need to set here as well self.age equals to age. When we do something in style of with the equal sign here, equal operator, it will call the setter by default. This setter code will be run. And whenever we just do self.age, then the getter code will run. This part is the getter, this part is the setter. And the thing with this is that the setter will have a lot of validation that will protect our age. What you do now is that, for example, I'll just copy this one. I'll take this example again. Person 5. Let's say Natalie, for example. You're 4 years old. Person 5. This one works. Because it works because we have it went through the validation. And then if we take person 5.age equals -3, you can see there's a value error, and which says age must be between 0 and 124, not -3. If I take 125, and you can see it fails as well. Good. Here I will try except value error as error, print error. That is quite cool. Now we are able to protect it. You can see we protect it with some validation codes that the input is as we expect. What we can also try out is that I'll just copy this one. I will try with a type error now. Type error, person. I will create a new person here. Just to show you that even in the dunder init, it will work. Instead, I will do something like this, a string for, and you can see age must be of type int, not class string. That means we have done some validation on the name and done validation on the age. However, take a look into this code now. It's becoming bloated. If we are going to do more validations, we do the gender as well, we need to validate that one as well. Well, you could make it more dry by lifting out some stuffs into some functions, and you can do some Other things, we've done the set and done the get, of course. There's a lot of things you can do. But this is like a normal way in OOP to, like a naive way to do validation. However, now we will try to do validation, but we will go into Pydantic to see how that will look. Remember, the code looks like this. And now we will move on to Pydantic. Validate using Pydantic. To do validation using Pydantic, you need to start with importing from Pydantic. Import, let's say import base model. Base model is a class which we will inherit from. And by inheriting from the base model, our class becomes a Pydantic model. But it's still a class. Remember, it's still a class as normal, but it's also a Pydantic model. And as a Pydantic model, there is some really nice benefits. I'll show you. Class, person, it inherits from base model. Then what you do is that you do type hinting. For the syntax is basically type hinting. We do the same as before, but now we have name, colon, string. This is a field. Gender, colon, string. Age, colon, int. And now we have our person class. We can do person, how much is I'm up to? 6. We can do like person name equals Christina. Gender equals to female, and we have age equals to 29, for example. Person 6. Oh, we got a wrapper for free. Oh, that was nice. We got done the wrapper for free. We didn't need to implement it as we did before. That was one thing. Can we do something like this? Person 6.age. Yes, we got 29. Nice. Person 6.age equals to 36. Person 6, 36. Great, it works. However, can I do something like this? Person 6.age equals to 30. And that works, strangely enough. Person 6, you can see it becomes 30. Apparently it works. But let me show you something else. Let's create a person where it fails. Person. I will come back to this issue later on. I will say issue here. Person of, say, we have some numbers here, for example. And you can see there's a validation error. Try accept validation error. Then we need to import that from Pydantic. Import validation error. Accept validation error as error. Print. Yes, this is the validation error that we get. Name input should be a valid string. You can see type, string type. Input value is this. Input type is int. That is not. However, I could do something in style of this. For example, copy this one. Person. I say quote 29. And I say here is, for example, this one works because the quote 29 is coerced into 29. This string 29 is coerced into 29. It works. You can see there's no quotes here in this 29. However, we still get an issue. We can change it afterwards. In order to stop us to change it afterwards, what you need to do is that we copy this person here. We copy this person, and what we should do is to also add in model config. Model config equals to from Pydantic import config dict. We do a config dict and we say assignment validate assignment equals to true. When we do this, you can see what will happen when we, for example, we say that this is a person. This is just to show you how Pydantic works. Person 7, you can see, it works. We have coerced it to an age that works. Person 7 dot age equals to 30, for example. Yeah, this can be 30. And we get a validation error. That is great. I will just copy my validation error as before. Copy this one, and we get one validation error. Now when we're changing the attribute, we try to assign to this attribute. Assign to this age, and now we get validation on it as well. You can see one validation error for person. We can see 30, input type string. It should be int parsing. Person 7 dot age equals 10 will work. Person 7, you can see it works. Now the age is 10. That is some examples, and we can show some more examples. For example, I can use another try except here, and let's create another person here. Person, I will try to fail in several places. Name equals to 3.1415, gender equals to 2.714, age equals to -4, for example. And you can see it fails it gives 2 validation errors. You can see it fails in several, and that is quite nice that you can know which places it has failed. It has failed in name and gender. However, the age, we haven't actually done validation for negative values. We'll fix that as well. Now, when you have this, you can change it. You know that the name needs to be changed to Sofia, for example, and the gender, we say, yeah. And now it works, but the problem is that the age is still negative. We need to fix the person class with some age validation. Let's add age validation. I will go back and copy from my previous code. Let's see, here is the code. This is the code. You can see the class is quite neat. It's quite short. We want to have some validation on the age as well. From Pydantic, import field. So the field is used to do validation. Here we can do equals to field, and it should be greater than -1. It should be less than, let's see, did I say 125 before? I don't remember. Less than 125. This means that if we do something in style of this one, we see that we get a validation error for person. We can see input should be greater than -1. That is quite nice. We have, by default, we have really nice validation by having like very simple code like this. And also, of course, we could do some more validation. We could do something more here. We could, for example, from typing, import literal. Since I've used M and F here, we can do like this. Gender should be a literal M, F. If I do fem like this, you can see this one fails as well. Input should be M or F. Now what we got fem. That is quite neat. We have, and now this is like very useful for example, when we're working with FastAPI later on. We will create our own APIs. And when you're creating API, you need to be able to validate code. You need to validate data, and you need to output into JSON. You need to do something called serializations and deserializations. Serialization means that we go from an object back to a JSON string, And deserialization is that we go from a JSON into an object in a Python instance. And the thing is that object is really nice to work with in Python. However, when we're sending data back and forth through an API, then we need to do that through JSON. That is a standard. That's why we need to change it back and forth from JSON. Then we need to do some serialization and deserialization. And Pydantic supports that. FastAPI builds a lot upon Pydantic. And also we will, if you're following me, of course, I will go into some AI. And for AI, we will use a lot of Pydantic to structure the output from LLMs. Pydantic is, I will refer to it a lot. You need to learn Pydantic. Let's take a look into person 7. This is Nina, gender F and age 10. I do model done. And you can see this is a dictionary. And if I go from this is, we do a serialization here. And when you have it as a dictionary, you could, for example, do something in style of this. I'll copy this one. I'll do we open, let's say open person.json in mode as F or as file. And then I will do import JSON, and I will do JSON.dump, and I will copy this one inside here, comma file. When I do this one, I get this person.json. If I click on this one, you can see this is the data that we have dumped into this file, this person.json file. You can see that if we have dumped it, we can go back also. Now we have written to a JSON. Now we want to do deserialization. And to do deserialization, basically what you do is to do we open person.json as read, as file, and we do JSON data equals to file.read. Now you can see it's JSON data. It looks like this. It has a string here. This is serialized. I'll just do a print here that you can see that. Actually print wrapper of this one. Wrapper like this, and you can see there's a quote there. It's a string. And now I want to deserialize it. Person, actually the deserialization happens here. Person.model validate JSON. I model validate this JSON data basically. And you can see, I got back my instance. That is really cool. We can serialize, we can deserialize with the help of Pydantic. We have done a lot of validation with very little code. I hope that this was helpful for you. Let's take out the terminal and git add dot git commit -n Pedantic basics, and then do git push as well. In this video, we have gone into Pydantic for validation, that we can work with data in an OOP manner. You can go from OOP instances back into JSON, and from JSON back into OOP instances. That is really cool since, for example, I talked about FastAPI, when you need to create an API and you need to send data back and forth, and that is through JSON. And when you have sent data or received data in JSON, then you can make it deserialize into Python objects, which you can work with. And also you can go from Python objects and serialize it back into JSON and then send it to someone else to get that data. And also with Pydantic validation, that is really useful when we're working with LLMs. As you've seen that a lot of LLMs get a lot of unstructured data. We need to structure it in a certain way. And a lot of frameworks use Pydantic under the hood to make the data structured. This is the foundation of everything. I hope that you learned a lot in this video. And there's another video I have in Pydantic where I go into Pydantic together with an API. I use Pokemon API. Take a look into that as well, that you learn how to validate the data that comes from an API. And then later on, I also have a lot of videos in FastAPI, where Pydantic plays a larger role there as well. And also Pydantic in LLMs, of course. In particular, Gemini I have used because they have really nice free tier. Thank you for watching this video and see you in the next one. Bye.